molecules. In this video, we will discuss about sigma and pi bonds. So one of the basic thing then that whenever s orbitals overlap each other, there is a formation of a sigma bond. So when ss orbital, you can see here, when ss orbital overlap, this is the formation of a sigma bond. Sometimes s and p orbital overlap, this is also a sigma bond. But whenever p orbital they overlap, this is the formation of a pi bond. So just by the front page, it will let you know that how the sigma and pi bonds are formed. So let's start the video. Bonding in organic molecules, sigma bond. The single covalent bonds are known as the sigma bond. The pair of electron in the sigma bond is found in the region of space described as a lobe between the nuclei of two atoms sharing the electrons. In many organic compounds, each carbon atom forms four sigma bonds, and in this way, there is a formation of a tetrahedral. The tetrahedral bond angle is 109.5 degrees. Each carbon atom has 6 electrons with an electron configuration of 1s2, 2s2, 2p2. This means that carbon has 4 electrons in its outermost shell by forming a single covalent bond with 4 other atoms. A carbon atom can gain the electron configuration of the noble gas, it means the neon. So you can see here, these are the sigma bonds. These are all sigma bonds. In many organic compounds, each carbon atom forms 4 sigma bonds, which are all areas of the negative charge around each carbon atom repel each other. The position themselves is a tetrahedral, and as I have already described, there is a bond angle of 109.5 degrees. Pi bonds. Carbon can also form double bond and triple bonds between its atoms in the organic molecules as well as forming single bonds. So CC double bond found in alkenes like ethene made up of a pi bond. The carbon atoms involved in a double bond will each form 3 sigma bonds. This is an example of sp2 hybridization. This leaves each carbon atom with one spare outer electron in the 2p orbital. When these 2p orbitals overlap, they form the pi bond. So the overlap of 2p orbital results in the pi bond. Ethene described as a planar molecule, and the bond angle in between them is 120 degrees. All the carbon hydrogen atoms in the ethene molecule lie in the same plane. The two carbon atoms are said to be sp2 hybridized. The two layers that make up the pi bond lie above and below the plane of atoms in an ethene molecule. Carbon atoms can also form triple bonds. These are found in homologous series of alkynes. The simplest example of alkyne is ethyne. And in this one, the carbon atom is sp hybridized. Sp means one s and one p orbital. This leaves two electrons in different p orbitals on each bonding carbon atom. The p orbital overlap forming two pi bonds which contain two electrons. The two lobes of pi bond lie above below the plane of atoms in the ethene molecule as in ethene, as you can see here. The two lobes of the other pi bond lie in front and behind a plane of atoms in the ethene molecule. This maximizes overlap of p orbitals, which in fact form a cylinder of electron density around two carbon atoms. The ethene molecule is a linear shape with all atoms arranged in the straight line. In this, actually, there is overlapping of 4 p orbitals, which results 2 pi bonds. Ethine described as a linear molecule. The two carbon atoms are both hydrogen atoms in the ethine molecule. The two carbon atoms are said to be sp hybridized. This is a table which is showing that on the basis of the number of the steric number of electrons, number of bonding pair, number of lone pair, we can predict the bond angle and the shape of any molecule. So the same thing for this table. How to use the table? There are some rules like the best way to understand a table if we discuss an example, a working example. Now this is a working example. Draw the Lewis structure. The Lewis structure draw here or like this. Select the chlorine. Now in this way chlorine has a central atom. You can see how many electrons are present around the chlorine. It is 1, 2, 3 and 1 pair is here. So steric number is 4. How many bonding pair? There is only one bonding pair. So there are only two atoms in the molecule. So the only way they can arrange between them is uh, linear, and the bond angle is 180 degree. In this example again, how many bonding pair? So carbon is the central atom. What is the steric number? You can see the steric number is 4. How the steric number is 4? The steric number is 4. Determine the number of bonding pairs, 4 pairs of electrons around the 4 pair of electrons, 1, 2, 3 and 4 pair of electrons. So and there are two sets of electrons. Why? two sets of bonding pair of electron will repel each other so that they get as far away from each other as possible. This is the bond angle between them will be 180 degree and the molecule is again linear. Actually in here we are consider this one a single bond pair and this one a single bond pair. But the total number of electrons around the carbon atom, total number of bonding pair is 1, 2, 3 and this one is 4. So that's why the steric number is 4. Let's discuss this one. Again, aluminum is a central atom. How many bonding pairs? What is the steric number? 1, 2, 3. 3 bonding pairs. And same is the steric number. There are no lone pair around the central atom. So the bonding pair electrons repel each other. So they get a bond angle. They repel each other up to 120 degree. So steric number in this one is 3. Bonding pair is 3. Lone pair is 0. Here again the carbon is the central atom. Steric number 4. Bonding pair 4. And there is no lone pair. So it is the angle is a tetrahedral, angle is 109.5 degree. Then again ammonia, bonding pair, the steric number 4, bonding pair 3, lone pair 1. So there is a repulsion between the electron pair and the bond angle is 109.5 degree with a trigonal pyramidal. So 3 lone pair, 3 bonding pair, 1 lone pair and steric number is 4. Water. Oxygen is a central atom. Steric number is 4. Bonding pair 2 and lone pair 2. So on the basis of this one, where the two bonding pair electrons are forced closer to each other, resulting in a bond angle between them of less than 109.5. So water has a bond angle less than 109.5 degree and its shape is bent. This is SF6. So steric number is 1, 2, 3, 4, 5, 6. Bonding pair. Bonding pair is 6. No lone pair. Shape is octahedral. Angle is 90 degree. No lone pair repulsion. Now this is a question from year 23 and the question is how many sigma bonds and how many pi bonds. Simple. CC single bond or the central bond is a sigma bond. CH bond is also a sigma bond. While if there are two bonds there, then it is a pi bond. So two pi bonds and this is one which is in yellow. This is a pi bond. All other are sigma bond. So there are 19 sigma bond, 3 pi bond. The answer will be D. That's it. This is the end of the video and see you in the next video. You can ask me question if you can send me question on this number or you can ask me in the discussion in the YouTube video. Thank you very much. See you in the next video. Allah Hafiz.